Algebraic and graphical solutions of linear equations. A linear equation in one variable has the form ax plus b equals 0. A linear equation in two variables has the form ax plus by equals c. Let's walk through finding the algebraic solutions for these equations first. Now we're solving for x. You'll notice though that the variable they use is y. So when they say solve for x, they really mean just in general solve for the independent variable or whatever variable is there. So we're going to go ahead and get rid of the parentheses by distributing. And don't forget to distribute that negative through there. And then we're going to get all of our y's on one side and all of our x's on the other side. And then divide by 12 on both sides. And we will get y equals 2. For an equation like this, we first want to clear our fractions. We can multiply both sides of the equation by 4 to clear this fraction, and multiply both sides by 3 to clear this fraction. So we could just go ahead and multiply both sides by 12 in order to clear both of those fractions. So remember, you have to multiply the entire side by 12, both sides. 4 goes into 12 3 times, so then I have 6x minus 9. And 3 goes into 12 4 times. 4 times x is 4. And then my 12 times 1, 4x. And then my 12 times 1 is plus 12. So we'll go ahead and get our x's on one side, subtracting 4x from both sides. And then add 9 to both sides to get all of the constants on one side. So you get x is 21 halves. Now for this last equation, we have two variables, x and y. They want us to solve for x if y is 18.73. So we just replace y with 18.73 in the other equation and solve as usual. You might use your calculator. We're going to take 18.73 and add 87.54, and that gives me 106.27. So 106.27 equals 12.56x. So we're going to take the 106.27 and divide by 12.56. And so I get x as approximately 8.46. Y was given in 2 decimal places, so we should follow suit and give x approximated to 2 decimal places. Now for applied problems, you need to remember to include units of measure with your answer. Make sure your answer makes sense in the problem situation. So in this example, we have credit card debt. It's hard for some people to pay off credit card debts in a reasonable period of time because of high interest rates. The interest paid on a $10,000 debt over 3 years is approximated by y equals 175.393x minus $116.287 when the interest rate is x%. Now, what is the interest rate if the amount of interest is $1,637.60? So the number that they gave you, the $1,637.60, is the amount of interest. So the interest paid is approximated by y. the interest rate is X%, so we're going to put this $1,637.60 in for Y. 1637.6 equals 175.393x minus 116.287. And we're going to go ahead and add 116.287 to both sides. 1637.6 plus 116.287. I get 1,753.887, and that is equal to 175.393x. So we're going to divide both sides by the 175.393, and we get an x of about 9.99975% is the interest rate. So putting the label of percent there is how you would answer this application problem. That's your unit of measure, is the percent. Now let's have a conversation about solutions, zeros, and x-intercepts again. When we have a number a for which f of a equals 0, that's called a zero of the function. If a is a real number, then a is an x-intercept of the graph of the function. Be careful. You need to write it as a comma 0. And then these are all numerically the same. So the x-intercept of the graph of the equation is a comma 0. The real zero of the function f is a, meaning if we put that number in as the input of the function, it will cause the function to equal 0. And the real solution to the equation f of x equals 0 is going to be x equals a. So they're represented in different ways. X-intercepts, intercepts are points, so you write them as points. Real zeros of the function, we write zeros as just being a number. And solutions to equations are also written as equations. So it needs to be an x equals a number. So for this function, f of x equals 13x minus 39, we are to find f of 3. F of 3 is equal to 13 times 3 minus 39. And so that simplifies to be 39 minus 39, which is 0. So f of 3 is 0. That means part B, the 0 of f of x equals 13x minus 39 is 3. Remember, a 0 is just recorded as a number. It's the number that if it were used as the input x, it would cause your function value, the output, to be 0. The x-intercept of the graph is going to be an x value of 3 giving a y value of 0, 3, 0. The solution to this equation, where 13x minus 39 equals 0, is x equals 3. So solutions to equations are also written as equations. X equals 3. In example 4, we want to look at this equation and solve it in two different ways, graphically, with our calculators. So the first method is the X-Intercept method. In order to set this up for X-Intercept method, what we have to do is get everything on one side equal to 0. So I'm going to subtract x over 3 from both sides. I'm going to subtract 1 from both sides, and this is the equation that I get. Now, coming over to your graphing calculator, you're going to put that in. 2x minus 3 in parentheses over 4 minus x over 3 minus 1, and there you go. And let's go ahead and do a standard zoom. So a zoom 6. Now it looks like we might be able to see where it's intersecting the x-axis over here, but let's go ahead and fix our window a little more. Just hit window and a little more to the right. So let's make the x max a 15 and regraph. And definitely I can see where it's crossing the x-axis. So now we'll go to second, calculate. We're going to calculate the 0. In other words, what is the x value when the y value is 0? The first question your calculator asks you is, what is the left bound? So just go somewhere to the left of where you're seeing that x-intercept and hit enter. And then go to the right, somewhere to the right. Okay, so somewhere to the right of where you see the x-intercept. Definitely we're to the right of it. You can see my y values where I'm tracing are now positive. So we're definitely to the right of the x-intercept. We'll go ahead and hit enter and have it guess. Go ahead and hit enter again, and we get 10.5 for our x. So x equals 10.5. The intersection method is a little bit different. What we'll do is set our left side of our equation in for y1. So y1 is going to be equal to 2x minus 3 all over 4. And y2 is going to be the right side of the equation. It'll be x over 3 plus 1. So we'll put that into the calculator. Parentheses, 2x minus 3, close parentheses, divided by 4. And then x over 3 plus 1. And then go ahead and let's pretend that we have not graphed this yet with the X-Intercept method. So let's do a zoom 6. And you can see it looks like maybe they're intersecting right at the edge of the screen, but we can't be sure. So again, we can go in and scoot the x value over a little bit and regraph it. And now we can definitely see where the lines are crossing. So we'll hit second and calculate, and we want to see where it is that they're intersecting. So we're going to hit option 5. The first question it asks is, what is the first curve? You see it flashing on that blue line, the y1 function. So hit enter. The next it asks, is this the second curve? And it's now on the red function, which is your y2 function. Hit enter. The reason it asks you that is you could have several functions on here, not just 2, and you need to identify which 2 graphs you want to find the intersection for. And so you can scroll up and down through your different graphs and select the 2 graphs that you want to intersect and guess. So go ahead and just hit enter again. And there we are at a 10.5, 4.5. Now notice in our original equation there is no y value. When we put this y1, y2 in our calculator, we're giving the graph a 2-dimensional representation, but there really is no y in our original equation. The x is the only thing that we are concerned with. So putting this into the calculator, we get an x of 10.5. In example 5, we have criminal sentences, and the function is given as y equals 0.55x minus 2.886, which describes the mean time y served for a crime as a function of the mean sentence length x, where x and y are measured in months. Define the sentence for a crime that would give an expected served time, or time served, of 10 years. Write an equation and solve it by using the X-Intercept method and then the intersection method. So let's go ahead with this here. Setting this up, we have y equals 0.55x minus 2.886. Now they've given expected time served of 10 years. So that is the mean time y served. And remember, it's going to be measured in months. And so that'd be a y of 120 months. All right, so we have two equations here. We can do method B first and use the intersection method. So you go to the y equals, you have 0.55x minus 2.886 and a y sub 2 of 120. Now this is a tall number. Your standard window is not going to fit that in. So we're going to need to do maybe a zoom fit to see. And it's way out there. It's way out there where those are going to be intersecting. So let's go ahead and fix our window from 0 to 200. Let's just try 200. Oop, not 2000. 200. And then we'll do a zoom fit. See if we can see the intersection. We're getting closer. So let's set our window to from 0 to 300. And right there, and zoom fit, and there we go. Now we can see the intersection in our window. We'll go ahead and do second, calculate, intersect, enter, 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 and we get this nice intersection point they've given us. Okay, so this shows us that at an x of 223.4, we have a y of 120. So this is the intersection method. We get 223.4 months served. Okay, and if we wanted to do this with the intercept, the X-Intercept method, that's going to be method A, then we would go ahead and put in here 120 equals 0.55x minus 2.886, and remember we want to get everything on one side equal to 0, so this would be negative 122.886, and go ahead and put that in the calculator. So I'll put in here to insert a 120 in front of that. Clear that out. And let's say that we had not done this with the intersection method already. Let's just do a standard zoom. It's definitely not going to show. So how would you know how to set your window? Well, think about you're trying to find the x. X is the, where it is, the mean sentence length. X is the mean sentence length. So if we're talking about time served 10 years, that's 120 months. So let's at least do a window where we go from 0 to 120 and do a zoom fit. And it looks like we're now starting here to get to the top. When you have a really grainy line up here, it means that the x-axis is way up there. So we need to move our window out even further. So let's try with 250 and do a zoom fit. And there we go. Now we have a very bold x-axis. That's because those tick marks are very close together. And we'll go ahead and calculate the 0. And left bound, sure, we can go there. And then we'll just keep on tracing over to the right until we get to the right of where we see the x-intercept is. You can see the y values are positive up there now, so we've definitely crossed the x-axis. Go ahead and hit enter, and it's going to guess for you. We'll calculate to the right of this line and to the left of this line. So guess, sure, go ahead and hit enter. It hops right onto that point where y is 0, and you get that answer there. So it could be a few decimal places different, but because of the approximating algorithms that are in your calculator where you set your left and right bounds, but in general, your answer is going to approximate to be the same as this other method. So we got here an x of 223.4. So x equals 223.4, and make sure you put the label on there of months. Literal equations. An equation that contains 2 or more letters that represent constants or variables is called a literal equation. Formulas are examples of literal equations. In example 6, we're doing simple interest. The formula for the future value of an investment of P dollars at simple interest rate R for T years is A equals P times the quantity of 1 plus RT. We need to solve this formula for R, the interest rate. Now this is a formula that you would commonly use in a finance or accounting course, and you would solve these different types of formulas such as this one so that you can set up different spreadsheets and be able to run numbers. So let's go ahead and first, we know the thing that we're trying to solve for is stuck in parentheses. We can't do anything with it there. So let's go ahead and distribute out so that R can get out of the parentheses. Now we want to isolate this term that has the R in it. So we'll go ahead and say A minus P is equal to PRT. Now we're going to completely isolate the R. It's being multiplied by P and T. So we do the inverse operation and divide by P and T. So R is going to be A minus P over PT. Be careful when you're doing these problems that you keep the case as it was written. So if it's an uppercase A, keep it uppercase A. Uppercase P, use it uppercase P. And the lowercase r and t, make sure that those are kept as lowercase r and t. Case is very important in finance, accounting, math, sciences, and just important that you stay consistent with those. You could have an uppercase A and a lowercase a in the same formula, and they're representing completely different things. So make sure that you don't just inadvertently change the case of these variables as you're solving. In example 7, we want to solve this equation for x. So you notice on this one we have the variable x in two places. We have it here and here. The first issue I want to tackle is that this x is in parentheses. So let's go ahead and distribute the 2 by multiplying over the parentheses so that that x is not in parentheses. And the other thing I don't like is that we have this fraction here. So what we'll do is multiply both sides by 3. That gives me 12x minus 6b equals 5cx. Okay, remember, we're solving for x. We have an x here and we have an x here. So what I can do is go ahead and subtract 5cx from both sides and add 6b to both sides so that I have my x's on the same side. Then I will factor the x out. That's the way you get it away from all the other stuff that it's with. And then x is equal to 6b over 12 minus 5c. So this is finished. Just make sure when you're solving that if you have solved for x, you should not have x anywhere in your the other side of your equation, or that would be a circular definition. In example 8, we're writing an equation in functional form and then graphing those equations. So if you have any of these equations, and we've been practicing this in previous sections, you want to get them equal to y so that you can get them into your calculator, into the graphing part of your calculator. As is, you can't do that. So what we'll do is solve for y so that we can put it into the y equals part of your calculator. Let's try this. We're going to subtract 2x from both sides, and then we're going to divide by -3. So y is a positive 2/3 x minus 4. We'll put that into the calculator, into the y equals menu. So 2/3 x minus 4. And they want a standard viewing window. So zoom standard automatically sets your window to be from -10 to 10 on the x and the y axes, and nice and quick, and you're done. You don't have to type those into the window settings and worry about typing it in wrong. Okay, so just zoom standard. On this next, we're going to solve for y again by subtracting x squared from both sides. Then we'll just divide both sides by 4. So y is a -1/4 x squared plus 1. Let's go ahead and put that into the calculator. It's a -1/4 x squared plus 1. And again, we're already on a standard zoom, but zoom 6 is the way you get a standard window if you have changed your window settings. And there's our nice graph. Our last problem has to do with direct variation. Two variables, x and y, are proportional to each other, or they vary directly, if their quotient is a constant. That is, y is directly proportional to x, or y varies directly as x. That's the language that they use. If x and y are related by this equation, y equals kx. K is the constant of proportionality. And this looks familiar because it looks similar to y equals mx, they've just replaced the slope with the k. K is the constant of proportionality, or the rate of change for direct variation. So in example 9, we have blood alcohol percent. We have the blood alcohol percent of a 130-pound man, which is directly proportional to the number of drinks consumed. And 3 drinks gives a blood alcohol percent of 0.087. We are to find the constant of proportionality and then find the blood alcohol percent from 5 drinks. So the first thing that we do is, since we know that it's directly proportional, we use the model y equals kx. Directly proportional just means that if one thing goes up, it causes the other thing to go up. If one thing goes down, it causes the other thing to go down. They are directly tied to each other. So instead of using y and x to better interpret this problem and set it up, let's give more meaningful variables to the problem instead of using y and x. First, we have the blood alcohol percent is directly proportional to the number of drinks consumed. So let's say that we let B equal the blood alcohol percent. And D is equal to the number of drinks consumed. Okay, so your blood alcohol percent, we're reading up here again, the blood alcohol percent is directly proportional, so you know you're going to have your constant of proportionality multiplying the number of drinks consumed. So B equals K times D. Let me rewrite my chicken scratch there. K times D. All right, now they've given us this information that 3 drinks gives a blood alcohol percent of 0.087. So K times 3 drinks gives a blood alcohol percent of 0.087. If we divide both sides by 3, we put that into the calculator. We're going to take 0.087, divide it by 3. We get 0.029. 0.029, which equals my K. All right, that's my constant of proportionality. Let's go ahead and make a model that we could calculate any blood alcohol percent using the model. So the blood alcohol percent is equal to 0.029 times the number of drinks consumed. So now we can find the blood alcohol percent from 5 drinks. So we simply take our model that we've made and replace D with 5. So we're multiplying our constant of proportionality by 5, and we get B equals 0.145. So 0.145% blood alcohol level is the answer. Make sure and put that label on there. That does it for the section, so go ahead and give your homework a try, and good luck.